Okay, we are gonna talk about today's section 3.6. It's the chain rule. We will talk about the chain rule. This part is a little bit tricky part, so I want you to listen very carefully for this section. Okay. Okay, when we look at this example, which is about a gear, we have three. Okay, we have three gears here. Gear A, gear B, gear C, and gear A makes X turns, gear B makes U turns, and gear C makes Y turns. And let's compare their circumferences, or we can compare their teeth. We count the teeth, and we see that, for example, Y is U over 2 because of the radius is 2, 1. And then you can also compare U with the gear A, and it's going to be gear B versus gear A gives us U is equal to 3x. Okay, this is because B turns 3 times for A is turning once. Okay, so the relationship between all these gears is Y is equal to U over 2, U is equal to 3 over X. Eventually, if you want to write Y, which is C, in terms of gear C, in terms of gear A, actually gear B, I'm sorry, then gear A, sorry, then you would get this relationship Y is equal to 3x over 2. And we want to know the relation, we want to see the change of rate of Y with respect to X, which is dy over dx. And if you take the derivative of this with respect to X, you're going to get 3 over 2. And but be careful here, when you write 3 over 2, 3 over 2 can be written as 1 over 2 times 3. This 1 over 2 comes from dy du right here, right? If you take the derivative of y with respect to u, you get dy over du. And then you have the 3, which is, it comes from this u is equal to 3x. If you take the derivative of u with respect to x, you get 3 here. So we have such a relationship. This is not a coincidence. This is actually a chain rule formula. This is a nice example to start with. So from now on, actually dy dx, if you want to find the rate of change of y with respect to x, you have to go through first dy du, and then you multiply this with du dx, and you get the result. Okay, so you can see this clearly on the right hand side as well. Dy dx is, I was looking at the picture most of the time, but let's go over this. Y is equal to 3 over 2x, which is 1 over 2 times 3x. It is the composition of y is equal to 1 over 2u and u is equal to 3x. So chain rule is about the composition of functions. So it could be 2 functions, 3 functions, whatever. But the goal in this section is to take the derivative of composition of several functions. How to do that? And here, if you want to find the derivative of y with respect to x, then you have to go through this other functions that you compose them to get the original function y. So you get the derivative of y with respect to x, you're going to get 3 over 2, but you have to first go to u, dy du, and then du dx, you get 3. So we get this relationship in here. So this is a really nice example. This is an engineering example, so it's really good. And I want to give you another example, which is here, example 1. We have the function y is equal to 3x squared plus 1 squared. So here it is a composition of 2 functions, which you can consider, for example, f as the square function, u squared, and